Hey kiddos, today we are going to actually do a little recap of all the forms. Okay, so looking at standard form, looking at root form, and looking at vertex form. Okay, so we're going to look at all three. So we're going to talk about all three and then we'll do an example of each together. So the first form that we're going to talk about is the standard form, which is y, or f of x, equals ax squared plus bx plus c. Now remember, very important that you have this ax squared plus bx plus c um, and everything on the side. So technically this could be 0 equals that because you want it to be solved in this form, okay? So based on this information, you should be able to identify your a value, b value, and your c value. Using that, you can find the vertex, which the x value of your vertex, remember our vertex is either a minimum point or it is a maximum point. So the x value of our vertex is going to be negative b divided by 2a. And then the y value is f of that, which means that all you have to do is whatever answer you get for your x value, you would simply just plug this number in to your quadratic function here and solve it and get a different number value for your y. The axis of symmetry, the AOS, is going to be x equals. Our axis of symmetry is going to be an equation that begins with x equals, and it's literally negative b divided by 2a. So notice you use that twice here. Y-intercept is just is the point where the parabola crosses the y-axis. So that'll be at 0, comma c, so whatever our c value is. And then to find the x-intercepts, aka the roots, aka zeros, you have two ways of finding it. You can either solve it by factoring, which we've been practicing, and then once you solve it for factoring, your two sets of parentheses, you would set them equal to 0 and solve for x. Or you can always use the beautiful quadratic formula, okay? Negative b plus or minus the square root of b squared, it shouldn't be positive, it's positive b squared, minus 4 times a times c, all divided by 2a. All right, so let's try that example. All right, so our first example is that we have f of x equal to 2x plus 9x plus 4. So the first thing that I'm going to identify is my a, b, and c. So I can see that our a value is 2, our b value is 9, and our c value is 4. All right, now that I know that, we can answer the rest of these questions. The axis of symmetry, which is that equation of x equals negative b divided by 2a. So that means I need to solve for negative b divided by 2a. So b is 9, so I'm going to plug that in here. So I get negative 9 divided by 2 times a, and a is 2. So that gives me negative 9 divided by 4. The question is, can we reduce that? No. So yes, our vertex is a not very good looking number. So it's negative 9 over 4, comma. Now to find the y value of our vertex, we're going to take that value and we're going to plug it in. Now, what we're going to do is we're going to make our lives a little bit easier since obviously I know most of you don't have one of our fancy calculators at home. So we are actually going to, instead of writing it as a fraction, we are going to actually write it as a decimal. It's a little bit easier to interpret. So it is negative 2.25. So now when we plug it in, because now to find the other part, we have to do this, which is f of negative 2.25. So I'm going to plug it in where I see the x's here. So I get 2 times negative 2.25 and you know what? That is missing something. That's supposed to be 2x squared. That's weird. So make that change there. Plus 9 times negative 2.25 plus 4. All right, so let's see what we get when we work that out. So when you worked out the first part, you hopefully remember that you have to do exponents first. So negative 2.25 squared and then times 2 gives you 10.125. Then I did 9 times negative 2.25, and that gave me negative 20.25, then brought down the plus 4. So when I combined all of these together, our answer is negative 6.125. So that is our vertex. And our axis of symmetry, then backtrack, is x equals negative 2.25 because it's the same as negative b divided by 2a. Sorry about that. Hopefully you filled it in already. And our y-intercept is 0, comma. Our c value is, yes, 4. All right, now remember, to find the roots, you have two different options. We can either solve by factoring, or we can use the quadratic formula. So I'm going to set up our quadratic formula, which you can probably already see that I do have set up and written down here already. So it's already with the blanks for me to put in what I need to. So it's negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. So all we need to do is plug in these values. So b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. And now we can break it down. All right, so when we work that out, we get negative 9 plus or minus the square root of 9 squared is 81, and then negative 4 times 2 times 4 gave me a negative 32, all divided by 4. We can simplify that even further to get negative 9 plus or minus square root of 81 minus 32. It's 49 divided by 4. Luckily for us, this is a perfect square, so it actually reduces perfectly. Remember, if you get a negative number there, then that would mean that this has no x-intercepts. So keep that in mind. So we would have negative 9 plus or minus 7 divided by 4. Now remember, at this point, this is where the problem splits into two problems, okay? The first one is going to be the negative 9 plus 7 divided by 4. And then your second problem is going to be the negative 9 minus 7 divided by 4. All right? So negative 9 plus 7, negative 2 over 4 reduces to negative 1/2. So my first root is negative 1/2 comma 0. And let's see what we get for the second one. Negative 9 minus 7 is actually negative 16. Divided by 4 is a negative 4. So we get negative 4, 0. All right, so for our sketch here, I went ahead and labeled a few things, and I have key information here that's going to help me sketch this. So I have a y-intercept at 0, 4. I have roots, or aka x-intercept, at negative 1/2 and negative 4. And then our vertex is at negative 2.25 and at negative 6. So we're just going to guesstimate about there. So that means our parabola looks something like this. All right, so for the domain, which is, left to right, notice I see arrows at the end, so that means it has no restrictions. So technically it is all real numbers. Okay, so, or you can write negative infinity less than or equal to x, which is less than or equal to positive infinity. Okay, either one is acceptable. Now the range does have a limit. our range, the lowest it goes is that negative 6.125, because I'm getting that from my vertex. So that's less than or equal to y, because notice it's a closed circle there, which is then less than or equal to. Going up, though, it goes forever, so it'd be to positive infinity. All right, so that would be our range for this graph. And we're done with that problem. All right, now looking at root form, which is y or f of x equals a times x minus r1 times x minus r2, where r1 and r2 are your x-intercepts. To find your y-intercept, you would do a times r1 times r2. To find the vertex, you just find your x, which is halfway between your r1 and r2. And then your axis of symmetry is going to be the equation x equals negative b divided by 2a. So let's look at this example. All right, so for the function of f of x equals 3 times x plus 4 times x minus 6, find the following. Now, the direction, remember, that depends on whether it's positive or negative, and what you have to look at are your 3, the x, and the x. And if you multiply those three values and you get a positive value, then the direction is opening upward. Okay, so in that case, 3 times x is 3x squared, which is positive, so it opens up. Now, our roots are the r1 and the r2. And when you take it out of the problem here, okay, you're going to basically make it the opposite. So my first root, it says plus 4, but technically it's actually a minus 4. And the second root, it says minus 6, but you take it the opposite, so it actually is a positive 6. Then to find the y-intercept, you take those three values, the a value, 3, times your r1 value, which is positive 4, looking back at the original function that they gave us, times our r2 value, which is negative 6. So if we multiply 3 times 4, which we know is 12, and multiply that by a negative 6, you end up with a negative 72. So the y-intercept is 0, negative 72. All right, so let's move on. And the third and final form, the vertex form, which is y or f of x equals a times x minus h squared plus k, where your vertex is the h comma k. Your AOS, or the axis of symmetry, is x equals h. Your y-intercept is where you would let x equals 0, okay, and you would end up technically with this a times negative h squared plus k when you let x equals 0, so that's why I wrote it here. Okay, so that's kind of a shortcut. So let's look at an example. All right, so example 3, notice they give us f of x equals x plus 4 squared. Notice it seems like we have a lot of missing information, so that's why I rewrote the problem. F of x equals, a is 1, because there's nothing here, so it's understood to be 1, times x plus 4 squared plus 0. Okay, so vertex is hk, h is here, so we would make that the opposite, and we would get negative 4, comma, k, which you know is located here, which is going to be, hey, 0. So the vertex is negative 4, 0. To find the y-intercept, you let x equal to 0. So we would end up with 1 times 4 squared plus 0. Well, 4 squared is 4 times 4, which is 16. 1 times 16 is 16. 16 plus 0 is still 16. So the y-intercept then is 0, 16. And our axis of symmetry is x equals h, and our h value is negative 4. So that is summing up everything, all three forms. Be prepared. It is going to be quiz time.